So part C in question 6, we have 7 over 10 minus 1 over 4 equals 9 over 20. So remember, subtracting fractions, we need to have the same denominator. So and we have to equal something over 20. So if we times the denominators by 2, we get from 10 to 20. So the numerator must be multiplied by 2. So it will be 7 multiplied by 2 is 14 minus, how do we get from 4 to 20? We multiply by 5. So we must multiply 1 by 5 as well. This is 14 take away 5. And this is equals 9 over 20. So writing 23 over 100 as a decimal. So this is similar to 23 divided by 100. So 23 divided by 100 is 0.2. This is 200. Have remaining of 300. So it's 3 times 100. So we have a remainder of 0. So the answer is 0.23. Write this as a percentage. So from decimals to percentage, we multiply by 100. This is 70%. Write 1 over 5 as a decimal. This is 1 divided by 5. So we have 0.2. Shading 75%. So we have how many? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 triangles. And we want to find 75. So this is 8 would equals to 100%. 50% is equals to 4. 25% is equals to 2. So we have 75% equals to 50% plus 25% equals 6. So we need to shade in 6 triangles. %of people on the train are asleep. What percentage of people on the train are not asleep? So remember that with probabilities, it always adds to 100%, and the people could only be asleep or not asleep. So we do 100% take 21%, it's equals to 79%. Question 8. On 1st January of 2016, Lee bought a boat for 170,000. The value of the boat depreciates by 8% per year. Work out the value of the boat on 1st Jan 2019. Give your answer to the correct nearest dollar. So 2016, 2017, 2018 and 2019. So we find out this is 1 year, 2 year, 3 years. So this would be 170,000 multiplied by, it's depreciating, so this means it's decreasing, so it's 100%. Take away 8% equals 92%. and change this into decimal multiplier by dividing by 100 is 0.92. 0.92 to the power of 3. And remember, your answer is correct to the nearest dollar. So it's 132,377. Find the highest common factor of 140 and 245. So I like to do my factor trees. So 140, I have 14 and 10, 2 and 7, prime numbers, 2 and 5, 245 can be split into 5 and 49, 7 and 7. And remember to draw a little diagram. So what do they have in common? 7 and 5, so they're in the middle. And this is 140, and this is 245. So we have 2 and 2, and here we have 7. So remember, the highest common factor is this area here. So we multiply 7 by 5 equals to 35. That's our answer. A machine has a buzzer that sounds every 15 minutes. The machine also has a bell that sounds every 80 minutes. The buzzer and bell sounds together at 10 a.m. Find the time at which they next sound together. So this is a question to find the lowest common multiplier. So there's two ways. The first way, you can list, you can start with 50 and 80. Just keep going until you reach the common multiplier. So the next would be 100, 150, 200, 250, 300, 350, 400, 80, 160, 240, 3 times 4 times times 1 times 2 times 3 times 4, 320 times 5, 400. So we have the common is after 400 minutes. So remember, 1 hour equals 60 minutes. So 400 minutes would equals to how many hours? 6 hours and 40 minutes. So we add 6 hours 40 minutes to 10 a.m. So 10 a.m. plus 6 hours 40 minutes, we reach, so it'd be 11, 12, 13, 14, 15, 16. So 1640 or 440. Alternatively, you can do your factor tree to find your lowest common factor between 50 and 80. So you have 5 and 10, 2 and 5, 8 and 10, 2 and 4, 2 and 2, 2 and 5. So remember your lowest common multiple. So draw your little diagrams. What's in the middle? So we have, this is 2 times 5 times 5. This is 2 times 2 times 2 times 2 times 5. What's in the common is your 2 and your 5. So we have 5 and 80. We have 2, 2, 2. So find the lowest common multiplier. We multiply them together. So this is equals to 5 multiplied by 2 times 5 times 2 times 2 times 2. Again, this gives you 400 minutes. Question 10. Find the multiples of 5. So multiples are 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20. So it's 20. The factors of 30. So remember, factors comes in pairs. So be 1 and 30, 2 and 15, 3 and 10, 5 and 6, and we have 6 from the list. The square numbers, remember square numbers is 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49. Oh, sorry, I missed the number. We have 9 here. The prime numbers, the smallest prime number is 2. Remember, prime numbers means it only have 2 factors, which is 1 and itself. So the first one is 2, 3, 5, 7, 11, 13, 17. So we have 17 here. Next question, we have 2 fractions or dividing by them. So step 1, we need to change the mixed number of fractions into improper fractions. So we do 4 multiplied by 3. This is 12, then plus 2. This is 14 over 3. Divide by 1 times 9 is 9, plus 1 is 10 over 9. And remember how we do fractions. We keep, change, flip. So we keep 14 over 3, change the sign to multiply, then we flip, it's 9 over 10, and you get this equals to 126 over 30, which is equals to 21 over 5, and this equals to 4 and 1 over 5. Question 12. Benson was on holiday in Kenya for 70 days. He was in Nairobi for 2 over 7 of his holiday. So we want to find out, so how many days was he in Nairobi? So we do 2 over 7. Remember, off in math means multiply. So multiplied by 70, we get 140 over 7. This is 20 days. So he was in Mombasa for 1 over 5 of the holiday. So remember, off means multiply in math. So 1 over 5 multiplied by 70 equals 70 divided by 5. This is equals to 14 days. And he was in Kisumu for 4 over 9 of the rest of this holiday. For the rest, so the important is for the rest of the holiday. So how many holidays has he had? So 20 plus 14 which is 34 days. So how many days do he have left? 70. Take away 34. It equals to 30 days, 36 days left. So remember, off means multiply. So 4 over 9 multiplied by 36 equals 16 days. So he was in this place for 16 days. So a lot of you missed a mark because the question asks you to give what fraction of this holiday was spent in Kasuma. So the total number of holiday is of 70, and he was here for 16 days. So you get a mark for writing 16 over 70, and this is also the same as 8.